Welcome in the fifth section of our course. In this section, we'll be reasoning about types and defaults. So firstly, we will start from interpreting not a number, cleaning for numeric data. So we will generate an example dataset with numbers. Some of those columns will have a not a number value instead of the meaningful value for a numeric column. We'll try to fix that. Next, we'll be replacing that not a number with a scalar data. So every type has a specific default that has some meaning and could be processed in the further chain of processing, and we will try to incorporate that type into default one. In the third video, we will see two techniques to fill missing values in a more clever way. So firstly, there will be a backward fill, taking a value that is before 1, and forward fill, taking a value that is after missing value. And in the last video, we'll be replacing generic values. So we will write a custom replacer that is able to replace outliers with meaningful data. And this is a first video in which we'll be interpreting not a number. So cleaning for numeric data. We'll start from installing Pandas. Actually, this will be a reminder of it because we done that in the previous section. Next, we'll be detecting missing values, not a numbers in this case. And we will be leveraging the isNull method helper that is available on the Pandas interface. So this is a reminder of installing Pandas. You need to go to that web page to check documentation, and if you are not interested in it, just type pip install pandas. So let's go to the example. So firstly, before we will start looking at those missing values, let's try to generate some random values in our dataset. We need to import pandas and will be an alias pd to make it shorter, and numpy as np alias. Next, we need to create a data frame using pandas. We are passing 3 arguments. First argument is actually an array. We are creating a multidimensional array that will have 2 rows and 2 columns. Next, we are giving those columns indexes. So first row will be indexed by the value 1 and second one by the value 3. Every row should have 2 columns as we denote here. So first row will have column key1 and value 1, then another row, another, and so on and so on. At this point we have data frame, but let's say that our data has not enough values and we want to have 3 rows instead of 2. We can call the reindex method and pass an array of column names, actually the indexes that will be referring our data. And important thing to note is here that we are passing 2 here, whereas here 2 is missing, so there is no such data in this random data set. At the end, we are just printing data frame, and let's see how this code behaves. We can see that our data has 3 rows, 1 to 3, and 2 columns. First row has some random double float data, value 1 as well, third column also, but second one is missing. There is no data there, nor number data or any meaningful value. There is not a number here. So let's try to detect this number. In such low cardinality data set, we can do it by our hand, so human can do it. But in the real life, in the big data processing, there will be a lot of rows here, and we will not be able to do it manually. That's why we need to employ some logic and use helper methods. So here is exactly the same part as we analyzed in the previous example, but this time we want to analyze value 1 column and check it if it is null. So we can use isNull method that is available on the data frame to examine that specific column for every row that we are iterating over. So let's start this program. We can see that it returns false, true, false. As we remember in the previous here example, first one had value for value 1, second one didn't, and third one had that value. And leveraging data is null method, we are able to extract that information. And as expected, second row has true here because it has not a number. So very important fact to note here is that is null works for not a number as well as for nulls. So we can use that to create more generic and robust logic for our program.